Hi, my little mathematicians. Today is Saturday, March 28th, but this video will be posted on Monday, March 30th. And just to kind of review or recall what we were doing on Friday, we worked on fractions of a ruler as a way to start reviewing fractions again, because it's been a few units since we've gone deep into fractions. Today, we're going to kind of shift a little bit our focus, right? Like, we're going to still focus on fractions, but it's going to seem a little different from what we've done before. We're going to actually start with the do now to review what we've been doing in the last few videos, which was multiplying a single digit number by a two-digit number using the distributive property / the area model. So we're going to start doing that. Just 1 second as I share my screen. All right. So let's go into present mode, and here we go. So our do now, 28 times 5 equals n. You're going to use the distributive property in order to find partial products that you can multiply efficiently. Represent your answer using an area model. If you haven't already, take out your math notebook and you're multiplying 28 times 5. Sure, you could do repeated addition, but I'm going to ask you to move away from that strategy because we're looking to use more efficient strategies, such as the distributive property, like decomposing one of your factors and then using the area model to represent that work. So go do that now. All right, hopefully you tried it on your own. It's good practice. Even if you made a mistake, it's okay. That's what we're here for, so that we can learn. I'm going to turn on my markers and pens so that we can do this together. And 1 second as I do that. All right, so I know that I want to decompose one of my factors. 5 is a friendly number, so I'm going to decompose that 28. So let's start doing that. I'm going to type out my distributive property equation. So 28 times 5 is the same as, what can I decompose that 28 into? Well, 20 is a friendly number and 8 is a pretty friendly number as well. So I'm gonna multiply 20 times 5 plus 8 times 5. And I'm just gonna use a marker just to show you once more how I'm decomposing that 28. So I decomposed a 28 into a 20 and I decomposed it into an 8 and I'm multiplying it by the other factor. I'm going to solve using this distributive property equation, and then I'm going to use my area model to represent it. So 20 times 5, I know it already, awesome. If I'm not sure, it's 5 groups of 20. So 20, 40, 60, 80, 100. 20 times 5 is 100. And then I'm adding the rest. 8 times 5 is going to give me 40, right? So my total is 140. N equals 140. But remember, I want to use an area model to ensure that I'm correctly getting to the correct product, right? I'm finding my product. So I'm going to draw out my area model. I'm going to use maybe a different color, mix it up a little bit, Miss Maldonado. Let's do a dark blue. So I'm going to do, I multiplied 5 times 20 is my first equation. And then I'm going to add another one at the end. And I multiplied 8 times 5. It's not going to be as long, right? It's not going to be as long as my other rectangle. And I did not mean to do that. 1 second, guys. Okay, so that's not perfect, but it's fine. Not a big deal. I'm going to label it. So let's see. I multiplied 5. So that's my height times 20. That's my width. 5 times 20. I did that and that gave me 100. And then I multiplied 5 times 8. And that gave me 40. So again, here's my area model represented, right? I'm showing how the distributive property can be represented using that area model. So if you didn't do that or yours doesn't look similar, just take a moment to pause the video and kind of review what I did and make sense of it and write it down in your own notebook. Do that now if you need to pause it, because I'm about to clear everything and go to the next thing. All right, so I'm going to clear things. Hopefully you were able to kind of make sense of it a little bit. Remember, you can ask me questions. A lot of my friends have written in the comments below when they don't understand something, and I've tried to reach out asking, like, can you be more specific? Like, what doesn't make sense? I'm going to try to do reviews throughout the video, so in case you miss something. Also, I've had parents call me when they're confused, so please just feel confident in asking me questions or asking either of us a question. So now we're going to go to our next part of our lesson, which is our learning intentions. As always, the learning intentions serve a purpose, so we know what we're doing and we know what we're focusing on. So our learning intention for today, we are going to explore, say it with me, fractions of a set. Success criteria. How do I know that I'm successful, that I'm able to do this? Well, by the end of our math lesson today, you can identify different fractions for a set of objects. And that's going to make a lot of sense towards the end of the video. Language intention, I use words from our fractions anchor chart. And social intention, I do the work even when no one is looking. So let's start with reviewing our fraction vocabulary like we always do. Remember, if I do the gesture, you do the gesture at home, and you can say the word out loud. So say it with me: numerator, denominator, benchmark fraction, 1/2, part, whole, partition, equal parts, equivalent, greater than, less than, equal to. We have a bar model, we have a pie model, we have the number line, unit fraction, fractions greater than a whole. And here are some of the models and strategies that we use when we discuss fractions. Remember pie model. I love that pie model, it's awesome, but in 3rd grade, we've noticed that some of you have a difficulty or have difficulties with partitioning equally. And so your parts sometimes aren't equal, and then it really what ends up happening is that you make mistakes. Then we have that bar model where we do side by side to compare fractions, our number line model, and our awesome claims that we always go back to. I'm not going to read off the claims today because we're not going to necessarily use them today, but in another video we will discuss our fractional claims once more. All right, so we're going to move on to our number talk. Make sure you have your math notebook because I will ask you to write at any point during this video. So Miss Delgado was eating Fruit Loops for breakfast one day. She loves Fruit Loops. She poured 12 Fruit Loops and wondered the following: what fraction of these Fruit Loops are red, blue, yellow, green, orange, and purple? So I want you to look at the Fruit Loops that I have drawn on the side where I'm pointing to with my cursor. And I want you to just start by writing down how many red Fruit Loops do you see? What fraction of the Fruit Loops are red? Write that down in your notebook. For the red, you're going to write the fraction. For blue, I also want you to notice how many blue Fruit Loops are there. What fraction would you write to represent that? The same for the other colors, for yellow, for green, for orange, and for purple. So pause me right now so that you can go write that in your notebook. And you can even add, if you have coloring pencils or markers or crayons at home and you want to draw it out in your notebook, the little Fruit Loops, go for it. All right, we're back. So that means that you were able to write down, or you tried to write down, the fractions for each of these colors. I'm going to take out my annotating pencils and pens. And let's start by looking at the red Fruit Loops. So first of all, I'm just going to make sure I do have 12 Fruit Loops. It says she poured 12 Fruit Loops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we do have, in fact, we do have 12 Fruit Loops. And I'm looking for how many reds I see. So I see 1, 2, 3, 4. So that means 4 out of the 12 Fruit Loops are red Fruit Loops, which means we have a fraction. We have 4/12. 4/12 of our Fruit Loops are red. Okay, now let's keep going. Let's see blue. For blue, how many Fruit Loops do I have? Well, I have 2 out of the 12, or 2/12 of my Fruit Loops, right, are blue. Now I'm going to change it to yellow. I'm looking, I only have 1 yellow Fruit Loop, so I'm going to just write 1 out of the 12, or 1/12. of my Fruit Loops are yellow. Let's look at the orange ones. It seems I only have 1/12. My Fruit Loops are orange, and I forgot to change my color. So 1 second as I do that. So 1/12 of my Fruit Loops are orange. And then lastly, look at how many purple Fruit Loops we have. Let's see. Oh man, I just noticed I made a mistake. I did orange down here, and yellow should have gone up there. So give me 1 second as I erase that. So for yellow, 1/12, orange is 1/12, and then let me do green. I completely overlooked my green Fruit Loops, 4 green Fruit Loops. I have 2 green Fruit Loops, so I'm gonna write 2/12s. And then let's look at the purple ones. It seems we also only have 2 purple, so I'm gonna change it to purple right now. So out of my Fruit Loops, I only have 2/12s. Okay, let's look at that one more time. So for red Fruit Loops, 4/12s, for blue, 2/12s, for yellow, 1/12, for green Fruit Loops, 2/12s, orange, 1/12, and purple, 2/12s. So give yourself a big check mark if you're able to figure out what fractions we had for each of these Fruit Loops. And this is a new concept, guys. Remember I said we're going back into fractions. We're gonna focus a little bit more on this new topic of the fraction world called fractions of a set. So I want you to make sure you go down in your math notebook to the next little clean section or next clean page because I ask you to write. 1 second as I get out of this ad. I'm gonna clear all of this in a second. Clear all drawings. And then let's do the next. We're gonna take some notes. 1 second. All right, so this is where we're gonna take some notes in our math notebook. So most of the year we've been focused on fractions of a whole or fractions greater than a whole. So for instance, earlier on in the year, like we were looking at pizza pies, right? Like the pie model. And if this person cut it into fourths and I said I ate 1/4 of my pizza, right? I'm gonna shade in 1/4 just so that you can see it. This would be, that's a bad color. I'm gonna use a different color or use a different marker for that. If I said I ate 1/4 of my pizza, if I ate 1/4 of my pizza, that's what it would look like, right? I ate 1/4 of my pizza. So that's fractions of a whole, right? Today we're gonna shift our attention towards fractions of a set. So what's in green, what's highlighted in green that I'm about to read, I want you to write it down in your notes. Fraction of a whole is when a whole is divided into equal parts, while fractions of a set, I just noticed a mistake, sorry guys. Miss Maldonado. So while fractions of a set, it's an A. So fractions of a set deals with a group of objects. The numerator represents a specific number of parts, and the denominator represents the total number of parts in a set. What does that mean? Well, we just did it with the Fruit Loops. And here's another example using Skittles. I cut and copy pictures of different colored Skittles online, and I wrote down that 8/20 of my Skittles are red Skittles. There's a total number of 20 Skittles, but out of those 20 Skittles, 8 of them are red. And that's what fractions of a set is all about. So I want you to write down what's highlighted in green. And if it's helpful, you can also draw out the pizza pie where it says fractions of a whole and then fractions of a set with the Skittles if it's gonna help you understand it a little bit more. So pause me in order to do that. All right, so now we're back. So now we're gonna practice a little bit more with our fractions of a set. I'm gonna clear everything on here. And let's go to the next page. All right, so in your math notebook, not your math notebook, in your Bridges workbook, I want you to go to page 238. It has a set of instructions up there. We're kind of going to do a little bit of that, but I'm also going to do a few different things with you using this. So make sure you go to page 238 for this. So we're going to build different fractions. We're going to start with our friendly benchmark fraction 1/2. And what we have up here so far is one way to represent 1/2. And I want you to notice, if this was like a real carton of eggs, how many eggs represent 1/2, right? I want you to put it up in the air. I know I can't see you, but put it up in the air or say it out loud. So if you notice that 1/2 is the same as 6 eggs out of a carton of eggs, right? Because in a carton of eggs, it typically has 12 or a dozen. You're correct, right? So 6 eggs are shaded or 1/2 is shaded. Well, with fractions of a set, there's different ways that we can represent 1/2. And so we're going to do that together. You can take out your coloring pencils or markers or crayons to do it with me to make it colorful if you'd like. So that's just one way to represent 1/2. Here's another way. So I know that it's 6 eggs out of 12 because that's a half, right? That's the same as 1/2. So I'm thinking I can also represent 1/2 this way, because those are also 6 eggs. And it looks a little different, but if you notice, it's the same as 1/2. So I'm going to draw out my fraction, and you can do the same with me. That's another example of 1/2. I'm going to use a different color and try to represent it in a different way. I just have to remember that 1/2 is the same as 6 eggs out of a dozen or out of 12. So I'm wondering, what do you guys think about this? I'm going to do this and tell me what you think. I know it's 6 eggs representing half. If I said during the week I ate 1/2, right, of my eggs, would that be correct? And if you're saying yes, absolutely, even though they're not all lined up together or doubled up, right, like that, side by side, it doesn't matter. It's still 6 out of the 12 eggs. It doesn't matter how you shade it in or the order in which it's placed. So I'm going to write out 1/2 as well. Now I want you to try it. So with this one over here, see if you can represent 1/2 in another way. Go for it. All right, so now I'm going to try to represent another way, like another one, and I'm going to represent 1/2 in another way by shading it differently. So I just remember it's 6 out of the 12 that represents a half. So I could potentially just say, shade it in this way, that's 3 eggs, and then another 3 over here. And that would still give me 1/2. And while we're at it, let's think about fractions that are equivalent, because if there's a total number of 12 eggs, my friends, right? There's a total number of 12 eggs. How many eggs have I shaded every single time for each one? 6/12, right? So I could also say 1/2 or 6/12. Now we're gonna do a few different fractions. Now let's try a third. Let's say during the week I ate a third of my eggs. So I'm going to write out the fraction first in a different color. And a third. I'm thinking of what a third looks like. If I divide this into 3 parts, well, there's 12 eggs, and if I divide them into 3 parts, or 3 sections, that means each section would have 4 eggs. So let me draw that out first. Does that look like a third? Yeah, right? I'm going to shade it in. So this would be, if I said I ate a third of my eggs during the week, it means that I ate 4 out of the 12. So here are my equivalent fractions again, right? I'm going to use my another color. So 1/3 is the same as saying that I ate 4/12. How do I know that that's equal? Well, I can see it here clearly with the drawing, but if I multiplied 1 times 4, it would give me 4. And if I multiplied 3 times 4 by the same number, it would give me 12. So I know that those fractions are equivalent. Okay, so now what are we gonna do? That's 1/3. I wonder if we can represent 1/3 in another way. Knowing if I know 1/3 is the same as 4 eggs out of the 12, what's another way that you can represent 1/3 or 4/12? Go do that now in your notebook. All right, we're back. So let's try it. So I'm gonna grab my orange. So that was one way to represent it. I know it's 4 eggs. I could also shade it in this way because it's 4 out of the 12, and that would still represent 1/3 or 4/12 of my egg cartons. You could also do it like this, right? It doesn't matter the order. That's still 4/12. That's still 1/3 of the egg carton that I've eaten. And there's a few more ways that I can do it, but let's try some different fractions. So remember, this is the same as 1/3 or 4/12. Remember, if I'm doing it in my notebook, make sure you're doing it. Let's try dividing this into fourths now. So I'm gonna grab a different color again. Let's do green. I wanna find 1/4 of my egg carton. So if I have 12 eggs and I have to divide it into 4 sections, that means I would have 3 eggs in each section. So I'm gonna grab, so in each section I would have 3 eggs. So I might divide it like, let's do that again, undo. Nope, it's kind of hard to draw a line. So I'm trying to draw out my sections. So if I divide this into fourths in each section of my egg carton, I would have 3. That's fourths, right? So I'm gonna shade in 1/4 of that, just so you guys can see it. That would be 1/4. That means if I ate 1/4 of eggs during the week of my eggs, I only ate 3/12 of my eggs. So I'm gonna grab my other pen again. So 1/4 is the same as 3/12. All right, I want you to try to represent 1/4 and 4 3/12 in another way here. And another way here. So pause me to go do that. All right, and you probably paused me and now you're back. So here's another way to represent 1/4 or 3/12. Remember, it doesn't matter in the order in which you put it. I could also shade it in because I know 1/4 is the same as 3/12. So I could just shade in these 3 eggs. Or I could have shaded it like this, 1, 2, 3. There's so many different ways that you could have shaded. As long as you shaded 3 out of the 12, it's the same as 1/4. So for the last 4 fractions, I want you guys to try this all on your own, and I'm not going to come back on and do it with you. I just want you to practice it. I want you to show me 1/6, 1/6, 1/6 again, 1/6. And I really want you to figure out 1/6 is. Whenever you figure out what 1/6 is using your egg carton, what's the fraction that is equivalent to 1/6? So pause me now to jot down that last part so that you can do that independently. And I'm not going to go over that one with you. All right, so we're back. I'm going to clear my drawings. 1 second as I do that. Clear all drawings. And here's the last part of today. So today for our math lesson is our exit ticket. I know it's hard, in class I could just pass it out. You guys do it on a Post-it or index card, we pick it up. It's a little bit harder, but I am gonna ask you guys to try to do it at home and then send it to us so that we can look and see if you're understanding the concept. So you're gonna copy this egg carton into your math notebook and shade in, here you go, 1/6, right? That's the one I just had you practicing. So shade in 1/6 of the eggs, the color red, or any color you have. Honestly, it doesn't matter. There are many ways you can represent 1/6. Send it to Miss Maldonado's phone number. And then also remember, bonus, once you figure out what 1/6 looks like, how many eggs represents 1/6, right? Or what equivalent fraction is the same as 1/6. I can't wait to see your exit tickets, and I hope you have a fantastic rest of your Monday. Again, this video is for Monday. If you do see it a little earlier this weekend, it's because I just wanted to pre-film so that everything is ready for you guys on Monday. See you guys in our next math video. Bye.